Okay, perhaps you missed my lesson today on completing the square, or you just need a little reinforcement. Either way, we're going to be going over completing the square of a quadratic equation and using that to solve for x. This can be a very difficult topic. I've gotten better at it myself by getting some practice in, so if you have trouble, I always recommend, seek out some practice. There's always a lot of great resources online. And it's one of those things that's going to take some practice to help you get comfortable with it. So don't be intimidated if the first few problems seem a bit tough. The more you do it, the easier it gets. All right, so ultimately, if we had a quadratic before it looked unfactorable, we would just say, oh, unfactorable and move on. However, we're going to be looking at how you can take those unfactorable quadratics and then solving them by completing the square. It provides a visual. Some people like to have this visual in front of them. Some people are a little less visual. And they think, well, I'd rather just kind of have, something a little more concrete. But this is just kind of a visual explanation of what we're about to do here. All right, so for the first step, you're going to divide everything in your equation by a. Now, a is the coefficient of x squared. Why are we doing that? Because we don't want a coefficient in front of x squared. And if you do something to one part of your equation, you got to do it to the whole thing. So you'll notice I divided everything by a. And my second step here, I'm going to subtract c over a from each side. Because now my next step is I ultimately just want to have, as you can see them highlighted, ax squared over a plus bx over a. That's ultimately what I want to have left here. So to do that, right, I am going to subtract ca from each side. Now remember, in an equation, you can really do whatever you want to it, as long as you're doing the same thing to both sides of an equation and keeping it balanced. So in this case, we are subtracting ca from each side. And the goal is that we are just going to be left with this x squared plus bx over a. That's our goal. Our third step, this is where people get a little tripped up, but the more you do it, it'll make sense. You're going to add b over a divided by 2 squared to each side. And you'll notice that I have that highlighted here. So I have what I had before, x squared plus bx over a equals negative c over a. I'm adding b over a divided by 2 squared to each side. Your next step is to factor that new quadratic. So it should look like this, like x plus something squared, or x minus something squared. And then your last step is to solve for x. We're going to do a few examples here to help you get the hang of this. All right, so we're going to put b aside here. We're going to do a. Now, if you take a look, maybe you want to attempt to factor it first. You figure, okay, 3 and 1 are factors of 3. There's no way I can add those up to get an answer of 10. So I definitely have to do something here. Now, my first step, let's look for an a. Oh, nice. We don't have anything in front of x squared. We don't have to divide everything by a. Well, I mean, you could. I mean, you can put 1 here and then divide everything by 1. But guess what? It's going to leave you with what you started with. So that's good. It's a great way to start out. Next step, I'm going to subtract 3 from each side. That leaves me with x squared plus 10x equals negative 3. Here's what I want it looking like right now. All right, now here's the big leap. X squared plus 10x plus, we're going to take that coefficient, 10, b, what represents b, divide that by 2, and then we square it. And we're going to add that to each side. Now, why are we doing this? You're going to find out in a moment. If you do 10 divided by 2, you get 5. You square that, you get 25. So essentially, we're adding 25 to each side. And then you're left with x squared plus 10x plus 25 equals 22. All right. Now, what do? We're going to factor out x squared plus 10x plus 25. You can use the box method. A lot of people like using that, so we could use that here. I'll just zoom in here. So I want 2 factors of 25. Then when I add them together, give me positive 10. That gives me, how about 5? So I can write out my box method, x squared, positive 5x, positive 5x, and then 25 right here. And I just factor this out. I can factor out going horizontally first. I get x. I can factor out 5x and 5. I can factor out 5. I'm now going to go vertical. Boom. I can factor out vertically. I can factor out x. And when I factor vertically here, I get 5. It is not a coincidence that we have the same two terms here. That is our goal. That's what you should be getting. Because this is what our answer should look like. Well, we're not quite done, but x plus 5 squared equals 22. It's always going to be x plus something squared, or x minus something squared. That's the goal. And now we're in much better shape to solve this. So I'm just going to slide it over here so I have a little more room. Now to get x alone, my first step, since I'm squaring this, I'm going to square root it to get rid of that exponent of 2. I'm going to do that to both sides. And that leaves me with is x plus 5 equals, now I'm going to put plus or minus here. Why? Because for a square root, you can always have a positive or a negative answer. Like as an example, like I wanted to know the square root of 4. I'm not going to use that symbol, but I wanted to know the square root of 4 could either be 2 times 2 equals 4 or a negative 2 times negative 2 equals 4. So this plus or minus accounts for the fact that it could be positive or negative. Last but not least, I'm going to subtract 5 on each side, and I am done. So x equals negative 5 plus the square root of 22 or minus the square root of 22. And I've solved this by completing the square. Again, I attempted to divide each side by a. I subtracted c. I then took b, divided it by 2 and squared it, added it to each side. I then factored what I had remaining. Ended up with x plus 5 squared equaled 22. And then I solved for x by square rooting and then using basic inverse operations here. All right, so we're going to try another example now. We're going to try D. D is a little more difficult because, as you can see, we have a value for A here. So we're going to have to do a little more work. So since we have a value for A, we're going to divide everything by A. That leaves me with x squared minus 2x minus 4 equals 0. Now, you might be racking your head thinking, okay, what are two factors of negative 4 that add up to negative 2? You're not going to find them. They don't exist. So my next step, get rid of c. I'm going to add 4 to each side. I get x squared minus 2x equals 4. And I'm leaving a little bit of space here. All right, now here's the tricky part. X squared minus 2x plus, now in parentheses, I'm going to put b, which is negative 2 in this case, divided by 2, and I'm going to square it. And don't forget, you add that to both sides here, not just one side, both sides. What does that leave me with? I get x squared minus 2x, that hasn't changed. Negative 2 divided by 2 gives me negative 1. Negative 1 squared gives me positive 1. I'm just going to highlight this so we know what's going on. That's what I did here. And then that's still this. So then I am left with x squared minus 2x plus 1 equals 5. All right, now I need to factor this out. You can use the box method if you want to help you get there. Whoops. So I'm looking for two factors of positive 1 that add up to negative 2. Now I could do x squared. And hey, how about negative 1x? Hey, there you go, because negative 1 plus negative 1 gives me that negative 2. If I multiply negative 1 and negative 1, I get positive 1. So then we just start factoring. So from the top here, we're going to factor out x. From the bottom here, negative 1x and 1, we're going to factor out negative 1. Down here, I'm going to do the same thing. Remember, you're going vertical now, just like that. I can factor out x from here. And then here, I'm going to factor out -1, because remember, that first term's negative, so that means I'm going to be factoring out a negative. And you're looking, hey, you know you did it right because you're getting the same thing on the top and the bottom. I'm going to tuck that over here. So we get x minus 1 squared equals 5. Now we are ready to solve for x. I'm going to slide it over here. X minus 1 squared equals 5. Now I'm going to undo that by using the square root here. All right. Gives me x minus 1 equals the square root of 5. I'm up and make sure that's positive or negative square root of 5. I almost forgot that myself. Steps here, it's easy to forget one or two. And then I'm going to add 1 to each side, and I'm just about done. X equals 1 plus or minus the square root of 5. Why are we leaving it as the square root of 5? Well, because it's an irrational number, and frankly, it's a number that goes on forever. There's no need to simplify it at this point. We're not asking you to simplify any of your square roots right now. You can just leave them. Now, of course, if you have another teacher and you're watching this video, you might be expected to do that. All right, so we walked through a few of these. So, again, don't be intimidated. If you just follow your steps, you can get through this. Divide everything in the equation by a. Subtract c from each side. Then you're going to add b over a, divided by 2 squared to each side. Factor your new quadratic, which should look something like one of these two. And then solve for x. Hopefully this helps you guys.